Welcome to this explainer. Today, we're diving into a literal chemical mystery, the fascinating neuroscience of 2C-B. This is a molecule built entirely on extremes and scientific paradoxes. We're going to explore a compound that deliberately straddles the line between two completely different classes of drugs, and we'll unpack some absolutely groundbreaking clinical data that has only just emerged in 2025 and 2026 to explain exactly how it works in the brain.
So the story here actually kicks off with Alexander Shulgin. Back in 1974, this famous chemist synthesized the phenethylamine and cataloged it as one of his magical half-dozen. He affectionately dubbed it his great teacher because, well, it has this wild quirk. Just a tiny 2-milligram tweak could completely transform the entire nature of the experience. We'll get into exactly why that happens in just a bit.
Here is our roadmap for today. We'll breeze through its commercial history, look at its completely unique in-between subjective effects, the whole debate around its serotonin mechanism, some brand new 2026 brain scans, and finally, a really serious substitution hazard you absolutely need to know about. All right, Section 1, Shulgin's phenethylamine. Let's quickly trace how this molecule started and its totally rapid regulatory shifts.
From a chemistry standpoint, 2C-B is the founding member of the 2C family of phenylethylamines. Structurally, it's really just a simple chemical tweak away from the mescaline lineage. But its commercial history? Wild. Back in the 1980s, before it was controlled, it was actually sold legally in places like Germany and Dutch smart shops. They marketed it under names like Aerox and Nexus as, of all things, an aphrodisiac. Then, when MDMA was banned in the mid-80s, 2C-B just skyrocketed as a club replacement. Obviously, that rapid rise on the rave scene caught the DEA's attention fast, leading to emergency scheduling in 1994 and permanent Schedule I status by 1995.
Moving to Section 2, between MDMA and LSD. This is where we examine the molecule's most distinctive feature, its subjective paradox. So, the crucial thing to understand here is this tiny 2-milligram increment. Over the typical 12 to 24 milligram oral dosing range, the dose-response curve is ridiculously steep. It's literally like walking on a pharmacological razor's edge. If you get the dose even slightly wrong, you aren't just getting more of the same effect, you are stepping into an entirely different pharmacological experience.
And this brilliantly illustrates why people often call 2C-B a candy flip built into a single molecule. At lower doses, say 5 to 15 milligrams, the profile leans heavily toward an MDMA-like vibe, warmth, sociability, and sensory enhancement with hardly any hallucination. But push that dose just a bit higher into the 15 to 30 milligram range, and the LSD-like end suddenly takes over. You start getting geometric visuals, time dilation, and massive shifts in consciousness. So it essentially acts like a clear-headed empathogen at one end and a visual psychedelic at the other.
Section 3. The contested mechanism. To figure out why those effects shift so dramatically, we need to look under the hood at a genuine pharmacological paradox.
There is a genuinely massive debate in the scientific community right now about how 2C-B actually works at the receptor level. Like classic psychedelics, we know it's serotonergic, binding to the 5-HT2A, 2B, and 2C receptors. If you open a standard textbook, you'll probably see it confidently labeled a partial agonist at the 2A receptor. But honestly, we have to throw a red flag here. While it definitely binds to that receptor, its exact intrinsic efficacy is still highly contested in the literature.
Here's the wild part. Early functional studies back in 2004 used frog egg cells to test these receptors, and they concluded 2C-B was a low-efficacy partial agonist or even an antagonist, meaning it actually blocked serotonin's effect. But then, fast forward to 2007, newer studies using different cell systems and assays reported near full agonism. So the literature is totally split depending on the specific assay used. The general consensus, though, is that its activity is lower or more variable than full agonists like LSD or psilocin. And that lower efficacy actually helps explain why users report a much more clear-headed visual experience rather than heavy ego-threatening cognitive shifts.
Which brings us to Section 4, New 2026 Brain Scans. Let's see what modern neuroscience is finally uncovering about this molecule in actual human subjects. For about 50 years, 2C-B basically sat in a dark room, almost entirely unstudied in controlled human trials. But that is finally changing. A 2026 dose-finding study out of Basel did something amazing. Researchers rigorously tested this anecdotal intuition by directly comparing 2C-B against both MDMA and psilocybin in healthy volunteers.
They essentially proved in a lab setting exactly what Shulgin saw decades ago. 2C-B truly does straddle the subjective profiles of an empathogen and a classic psychedelic. But the absolute breakthrough here comes from molecular psychiatry. A 2026 Maastricht study used ultra-high-resolution 7 Tesla fMRI to directly compare the brain activity of 2C-B to psilocybin. The scans showed that 2C-B reduces within-network connectivity and increases communication between networks, which is your classic psychedelic signature of a more globally integrated brain. But crucially, the effects were way less extensive. It's essentially a lighter-touch version of psilocybin. Plus, it showed this totally distinct dopaminergic-linked signature, hinting that its interaction with dopamine actually shapes the experience, setting it completely apart from other psychedelics.
All right, Section 5, the deadly substitution hazard. We really need to untangle the molecule's direct toxicology from its severe real-world dangers.
This number 0 actually represents the total number of published deaths attributed to 2C-B alone in the scientific literature. Now, yes, taking way too much can cause a racing heart, hyperthermia, and some intensely scary hallucinations, but the direct physical risk of the actual molecule itself is surprisingly moderate. Shulgin himself once accidentally ingested 100 milligrams, which is several times a heavy dose, without any lasting physical harm.
However, there is a really terrifying catch. 2C-B happens to be the chemical parent to a class of compounds known as NBOMes. Because NBOMes are incredibly cheap to make, mind-blowingly potent, and active in microscopic microgram amounts, we're talking literally the size of a grain of salt, they are highly toxic. They have a punishing dose response and have tragically caused numerous hospitalizations and documented deaths.
Because of that extreme potency and cheapness, powders and blotter papers sold on the street as 2C-B are frequently swapped out with these deadly NBMO compounds. People have died thinking they were just taking a relatively mild dose of 2C-B. If you take literally anything away from this explainer, let it be this: drug checking and reagent testing are absolutely non-negotiable. The biggest danger by far is a contaminated supply chain, not necessarily the actual drug itself.
Now, beyond that severe substitution hazard, there are secondary risks we have to be objective about. 2C-B does have a narrower safety window than things like LSD or psilocybin. Pushing the dose too high brings on those toxic physical side effects we just mentioned. Plus, because 2C-B is metabolized primarily by the monoamine oxidase enzyme, dangerously mixing it with common MAOI antidepressants, SSRIs, or other stimulants creates a very severe risk of serotonin toxicity. It's a dangerous combo you definitely want to avoid.
So that leaves us with a pretty profound question to wrap things up. As human trials finally accelerate out of a 50-year blackout, the true potential of this molecule of paradoxes is only just starting to be unlocked. It's a compound where a tiny dose tweak punishes carelessness, yet its totally unique pharmacology gives us a rare window into the space directly between empathogenics and psychedelics. Will 2C-B just remain a misunderstood club drug? Or, as this new fMRI data comes into focus, will it become neuroscience's most valuable key to understanding how different brain networks shape human consciousness? Thank you so much for joining me on this explainer today, and as always, keep questioning what you think you know.